Morning everyone, and welcome to our 10.1 through 10.3 review. So what we're going to start with is 10.1. 10.1 just introduces us to the most basic parent function, quadratic function, and that is y equals x squared. So y equals x squared has a vertex of 0, 0 and an axis of symmetry, which is the axis or the line that cuts the parabola in half of x equals 0. So we're going to start by comparing these. So the first thing we're going to do is I want to draw the parent function on here. Now if you don't remember how to do that, I'm going to make a table. And I'm going to put 0 right in the middle. Now if y equals x squared, what I'm going to do is put 0 in for x. 0 squared is going to be 0. So I'll have a point at 0, 0 for sure. Then 1 and negative 1. If I put in 1 for x, I get 1 squared. Well, that's going to be 1. If I put negative 1 in, I get negative 1 squared, which is also 1. Then 2 and negative 2. 2 squared is going to be 4. Negative 2 squared is also going to be 4. Then I'm just going to graph those points. So 1, 1, negative 1, 1, 2, 4, negative 2, 4. And this is our parent function, our parent parabola. So what they want us to do though is compare that one to y equals 1/2 x squared minus 4. So I'm going to start again by putting 0 in. When I put 0 in, we have 0 squared times 1/2. So 0 times 1/2 is going to be 0. Then we'll have 0 minus 4, which gives me a negative 4. So 0, 1, 2, 3, 4. We'll have a point right there. Then if we put in negative 1 and 1, we'll get 1 squared, which is 1, times 1/2, which is 0.5, minus 4 gives us negative 3.5. So over 1 down negative 3.5, over negative 1 down negative 3.5, and finally 2 and negative 2. 2 squared is 4, times 1/2 is 2, minus 4 gives us a negative 2. So over 2 down negative 2, over negative 2 down negative 2. So this parabola is going to open like this. Now this, we have to talk whether it has a stretch or a shrink factor. If our A is less than 1 but greater than 0, it's going to have a shrink factor. If A is greater than 1, it's going to have a stretch factor. In this case, our A is 1/2, which is less than 1, so this is going to have a shrink. And it has a factor of 1/2. This one opens upwards. The axis that cuts this in half is x equals 0. And it has a vertex, or the lowest point, of 0, negative 4. Alright, now we're going to try this one again. We're going to compare something. So again, I'm going to put my parent graph on here. So 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. There's our parent. Now we need to figure out our other one, y equals 3x squared minus 6. So if we put in 0, 0 squared is 0 times 3 is 0. Minus 6 is going to be negative 6. Put in 1 and negative 1. 1 squared is 1 times 3 is 3. Minus 6 is negative 3. And if we put in 2 and negative 2, 2 squared is 4. 2 squared is 4 times 3 is 12. 12 minus 6 is 6. So if we graph that, we have 0, negative 1, 2, 3, 4, 5, 6. 1, negative 1, 2, 3. Negative 1, negative 3. 2, now we're going up, 1, 2, 3, 4, 5, 6. Same thing on the other side. So this time our parabola got a lot skinnier. It got a lot skinnier, so we can say that this parabola stretched. And we know that because a, which is 3, is greater than 1. This also opens up. It has an axis of symmetry of x equals 0. And it has a vertex, the lowest point in this case, of 0, negative 6. Now we're going to go on to one that's a little bit tougher. This time we have a polynomial, or a trinomial I should say. This is a real quadratic function here, one that you'll be seeing most often. First thing I'm going to look and see which way does it open. Well, if a is positive, then it's going to open up. If a is negative, then it's going to open down. In this case, our a is positive 1, so it's going to open upwards. Now it says find the axis of symmetry. So it says to find the axis of symmetry, we need to use the formula negative b divided by 2a. My a in this case is 1. My b comes next, which is negative 2. And my c is negative 3. So negative b is actually going to be a negative 2, because that negative from the b in front of the b. 2 times 1, which is a. So we're going to get 2 divided by 2. 2 divided by 2 is 1. Our x equals 1. So our axis of symmetry is x equals 1. Now the second part says plot and find the vertex. Now the vertex, we need to find a y. We already know what x is. We know that x is 1. So how we find our y is we plug that 1 back into our equation. So this time we'll have 1 squared minus 2 times 1 minus 3. 1 squared is 1. Negative 2 times 1 is negative 2. Then minus 3 equals y. 1 minus 2 is negative 1. Minus 3 more is a negative 4. So our vertex in this case is going to be 1, negative 4. Now it says plot 2 points. One should be C. Now C, that's our y-intercept. So that's where our line is going to cross the y-axis. So C is the y-intercept. In this case, C is negative 3. So that means C, our y-intercept, is going to have a point at 0, negative 3. So it looks to me like my vertex and my y-intercept, our x values are only 1 away. So what I know then is I can just draw a pretty standard graph. I don't need to shift it over or up or down at all. My vertex is at 1, negative 4. So 1, negative 1, 2, 3, 4. I know that's also my axis of symmetry, so I'm going to draw a line for an axis of symmetry. I know I have my y-intercept at 0, negative 3, so I got a point right there. Now it says reflect the point, so what I'm going to do is reflect that across the axis of symmetry. Our axis of symmetry is like a mirror. Now finally it says to just draw a parabola, so I'm going to draw a parabola. Alright, now we're going to talk about a couple that where we actually have to solve our equations. Now the number of solutions changes. We can have 2 solutions if we have 2 x-intercepts. We can have 1 solution if we have 1 x-intercept, or the parabola only touches the x-axis once. Or we can have no real solutions if we have no x-intercepts. So if it doesn't go through the x-axis at all. Alright, we are going to start by graphing this one. Now we need this in the form y equals ax squared plus bx plus c. Right now it looks like we need to move over a 4x. So I'm going to move that over by subtracting 4x. So we get x squared minus 4x plus 7 equals 0. Alright, so our first step to solving this is to find the axis of symmetry. We do that by finding negative b divided by 2a. In this case, our b, or let's say our a, is going to be 1. Our b is going to be negative 4. And our c is going to be 7. So negative b, well, that's going to be a negative 4. We have 2 times a, which is 1. So really we'll have a positive 4 over 2, which when we divide that, we find that x equals positive 2. Second, we have to find our vertex. Now we do that by plugging it in. We plug in our x to our equation. So we'll have 2 squared minus 4 times 2 plus 7. So y equals 4 minus 8 plus 7. 4 minus 8 is negative 4, plus 7 gives us a positive 3. So our vertex in this case is going to be our x of 2, our y of 3. Next comes our y-intercept. Our y-intercept is going to be c, and c equals a positive 7. So our y-intercept is going to be 0, 7. Now I know that the highest I'm going to go is 7, so I know that I'm going to want some space on my graph. So I'm going to bring this down just a little bit, so I'm not going to go immediately in the middle. I'm going to have some space on both sides so I can graph this. Our vertex is at 2, 1, 2, 3. Our axis of symmetry is right there at 2 as well. I know I have a y-intercept of 0, 7, so 0, 1, 2, 3, 4, 5, 6, 7. Then I'm just going to reflect that across the axis of symmetry. So I have 3 points, which will allow me to make my parabola. All right, last one. We have negative x squared plus 6x plus 16 equals 0. So first thing we got to do is find our axis of symmetry. Well, let's start out first by looking at our a. Our a is negative 1. Our b is going to be a positive 6. And our c is going to be 16. So our axis of symmetry is negative b divided by 2a. b in this case is negative 6, or 6, but we have that negative there. 2 times a negative 1. Negative 6 divided by negative 2 is going to give me a positive 3. So my x is going to equal 3. That's my axis of symmetry. Second comes the vertex. Vertex, I'm going to put what I found back into my equation. So I'll have a negative 3 squared plus 6 times 3 plus 16 equals 0. Or you should say equals y. Three squared is 9, but then that negative makes it a negative 9. 6 times 3 is 18, plus 16 equals y. Now negative 9 plus 18 is going to give us a positive 9. 9 plus 16 is going to give us 25. So in this case, y equals 25. Our vertex is at 25. So lastly, what we're finding is our y-intercept. Our y-intercept is going to be our c. This time our c is 16. Also, our point then we know is 0, 16 for our y-intercept. Now in this case, we have a very, very big vertex. That vertex is 3, 25. This graph only goes up to 20. So what I'm going to do is I'm not going to graph my vertex, I'm going to graph all the other points that I have. I'm going to put my x-axis all the way at the bottom, just so I have enough room for sure. Then I'm going to make sure my y-axis is far enough to the side where I can include other things. I'm going to put that there. My axis of symmetry is going to be at 1, 2, 3. And I know the y-intercept is at 0, 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What I do know is that that's reflected over across the axis of symmetry. So that is 1, 2, 3 away. So I'm going to count 1, 2, 3 to the other side. Now, in this case, I don't know which way this is going, if it's going up and down right now. How I figure that out is I look and see at my A. My A is a -1. If it's negative, I know it's going down. So I'm going to have a parabola that's going to come in going down. Now each parabola has its own natural curve, so I'm just going to follow that natural curve down to my points. So our solutions are going to be our x-intercepts, so here and here. Now it may not be exact, but I'm just going to look at my closest numbers. It looks like if this is my y-axis, this is going to be x equals a -2 because it's -2 away. And this is going to be over 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like x equals 9 as well. So the only way to fully figure out which ones are exact is to factor it, but we don't know factoring yet. So we're just going to get as close as we can. I'm going to go back to this last slide because I don't remember saying the solutions. The solutions to this one is our x-intercepts, but this one doesn't go through anything or through our x-axis. So this one actually has no solutions.